Every Amazon EC2 instance you launch starts life as a clone of something else. That something is an Amazon machine image, an AMI. Think of an AMI as a golden blueprint. The operating system, the application server, the apps, the disk layout, all frozen into a reusable template. Without it, there is no instance. With it, you can spin up one server or 1,000 identical ones in minutes. In this lecture, we will unpack what lives inside an AMI, why EBS backed images dominate real production, how the create, register, copy, deregister lifecycle actually works, the four places images come from, a full console walkthrough for building your own golden image, and the practices that keep those images secure and cheap. By the end, AMIs stop being a checkbox on the launch wizard and become a design decision you control. An AMI is not just a disk image with a fancy name. AWS packages three core pieces together. First, the root volume template. That is a snapshot of the root volume, almost always an EBS snapshot, holding the operating system and every package you installed. When an instance boots, this is what becomes its C drive equivalent. Second, launch permissions. These answer a simple question: which AWS accounts are allowed to launch instances from this AMI? You can keep it private to your account, share it with a partner account, or make it public. Third, the block device mapping. This is the recipe that says which volumes attach at launch. The root device may be a data volume on another EBS disk, maybe an instance store volume for Scratch. Change the mapping, and the same AMI can launch with a larger root disk or extra data disks without rebuilding the image. Together, template, permissions, and mapping fully define what launch this AMI means. Here is the split that decides how your instance behaves under stress. AMIs come in two storage flavors: EBS backed and instance store backed. EBS backed means the root volume lives on Elastic Block Store, network attached, snapshotable storage that survives the life of a single host. Instance store backed means the root lives on disks physically attached to the hypervisor host, and the AMI bundle itself sits in S3 until boot time. That one choice cascades into boot speed, whether you can stop the instance, how big the root can grow, and whether a host failure erases your data. Most modern workloads should pick EBS backed. Instance Store is a niche tool. Let's walk the comparison feature by feature so the trade offs stick. Boot time first. An EBS backed AMI usually comes up in under a minute because it boots straight from a network snapshot. An instance store backed AMI is slow, often several minutes, because the host must copy the entire image bundle down from S3 before the guest can start. Persistence: stop an EBS backed instance and the root data is still there when you start it again. Stop or fail an instance store root and that data is gone. It is ephemeral by design. Stop and start support follows the same line. EBS backed instances support stop, which parks the VM and stops the compute bill while keeping the disk. Instance store roots only allow reboot or terminate. Root size: EBS can go up to 64 terabytes depending on volume type. Instance store AMI bundles top out around 10 gigabytes for the root image. Durability is high for EBS because snapshots are replicated. Instance store durability is tied to one physical host. Cost-wise, you pay instance plus EBS storage, or instance plus S3 for the AMI bundle. Use cases make the choice obvious. Databases, production apps, and long-running servers want EBS. Caches, temp files, and purely stateless fleets can tolerate instance store. Let's make this concrete with two short examples. Example 1, a PostgreSQL primary. You need durable data, the ability to stop for a maintenance window without losing the data directory, fast recovery from snapshots, and room to grow the root or data volume. That is textbook EBS backed. If the host dies, the volume still exists and you attach it elsewhere. Example 2, a large distributed cache tier that rebuilds entirely from a central store on boot. Nodes are disposable. You might choose instance types that offer huge local NVMe instance store for raw speed and you accept that a stop or host failure wipes local state because the design already assumed that. Even then, many teams still boot from an EBS backed AMI and only put the cache files on instant store volumes, keeping the OS durable. The rule of thumb: default to EBS backed AMIs, use instant store for data paths that are already ephemeral, not for the operating system, unless you have a measured reason. AMIs move through a clear lifecycle: create, register, copy, and deregister. Create means you launch an instance, harden it, install patches and application code, then ask EC2 to create an image from that running or stopped instance. Register is what AWS does next. The AMI receives a unique ID like MI0A1B2C3D in a specific region, and it becomes selectable in the launch wizard. Copy matters because AMIs are region specific. An image born in US East 1 does not magically exist in EU West 1. You explicitly copy it, which creates a new AMI ID in the destination region and usually copies the underlying snapshots too. Deregister is how you retire an AMI so nobody can launch new instances from it. Here is the part teams forget. Deregistering the AMI does not delete the underlying EBS snapshot. That snapshot keeps billing you for storage until you delete it separately. Always pair deregister with a snapshot cleanup, or wire both into a lifecycle policy. Where do AMIs actually come from? 4 buckets. Amazon provided AMIs are the official AWS maintained images. Amazon Linux, official Windows Server builds, and similar. They are the safe default baseline, patched on a known cadence, documented, and free of third-party licensing surprises beyond the OS itself. AWS Marketplace AMIs are paid or BYOL images from third-party vendors. Think hardened security appliances, commercial databases, or pre-bundled analytics stacks. You pay the vendor's software charge on top of EC2. Community AMIs are images other AWS users shared publicly. They can be convenient, but treat them like unmarked USB drives. You do not control the build pipeline, so scan, verify, and prefer not to run sensitive workloads on them. Custom AMIs, your golden images, are the ones you build and own. You control the patch level, agents, CIS baselines, and app runtime. Mature accounts eventually standardize on a small set of custom golden images derived from Amazon-provided bases, not on random community picks. Creating a custom AMI is a straight path in the console, and the same ideas apply in the API or CLI. Step 1. Launch an instance from a trusted base AMI, typically an Amazon-provided Amazon Linux or Ubuntu image. Pick the instance type, network, and a security group that lets you administer it. Step 2. Connect and configure. Apply OS patches, install your runtime, ship application code or a configuration management agent, bake in monitoring and SSM agents, and remove leftover SSH keys or bash history you do not want cloned. Step 3. In the EC2 console, select the instance, open Actions, then Image and Templates, then Create Image. Give it a clear name and description. Include OS, role, and date, and confirm the block device mapping. EC2 snapshots the volumes and registers the new AMI. Step 4. Wait until the AMI status shows available. Only then launch new instances from it or copy it to other regions. A practical tip: stop the instance before create image if you want a fully consistent file system without relying on buffering tricks, especially for databases. A few details separate a usable golden image from a painful one. Name and tag aggressively. Include team, application, base OS version, and build identifier so 6 months later you know what AMI 0 A1B2C3D actually was. Revisit the block device mapping at create time. This is your chance to set a larger default root size or strip volumes you do not want every clone to attach. Know that creating an image does not automatically shut down source instances forever. Manage that lifecycle yourself. Test the AMI immediately. Launch a fresh instance in a clean subnet, confirm it boots, reaches your configuration management endpoint, and passes a smoke test before you mark the AMI as the new production standard. And remember region scope again. Available in one region means nothing in another until you copy. If you promote images across accounts, combine copy with explicit launch permission shares, or better, use a dedicated shared services account as the AMI publisher. Four best practices separate amateur AMI sprawl from a disciplined image pipeline. 1. Do not bake secrets. Never embed long lived AWS access keys, database passwords, or TLS private keys in an AMI. Anything on that disk will exist on every clone and in every snapshot. Inject secrets at boot with IAM roles for EC2, AWS Secrets Manager, or SSM Parameter Store. 2. Automate builds. Manual click around on a bastion images drift and cannot be reproduced. Use EC2 Image Builder or HashiCorp Packer so every image is a logged, versioned pipeline run from a known base. 3. Apply a lifecycle policy. Old AMIs and their snapshots silently accumulate cost. Amazon Data Lifecycle Manager can age out snapshots on a schedule. Pair that with deregistering unused AMIs. 4. Encrypt. Always encrypt AMIs at rest with KMS. Encryption protects snapshots, and when you share AMIs across accounts, you must also manage KMS key policy so the consumer can use the encrypted volumes. Security and cost both improve when these four are non-negotiable. Let us connect the pieces with two end-to-end scenarios. Scenario A, a regulated web tier. You start from an Amazon-provided Amazon Linux AMI, harden it with Image Builder, install the app runtime in a host agent, and produce an encrypted custom AMI in a central security account. You copy that AMI to every application region, grant launch permissions to workload accounts, and forbid marketplace and community AMIs via service control policies. Instances launch with an IAM role. No keys on disk, and pull secrets from Secrets Manager on first boot. Monthly, Image Builder ships a patched AMI. Data Lifecycle Manager retires snapshots older than 90 days after the AMI is deregistered. Scenario B, a batch analytics fleet. Workers are stateless. You still use an EBS-backed custom AMI for a reliable OS and pre-installed science stack, but scratch space lands on instant store volumes declared in the block device mapping. Jobs checkpoint to S3, so host loss is acceptable. Same lifecycle discipline, different persistence story on the data path. Notice both scenarios still treat the AMI as a versioned, encrypted, automated artifact, not a pet server someone configured by hand. So what should stick with you? An AMI is the template that defines every EC2 instance. Root volume contents, who may launch it, and which disks attach. Prefer EBS-backed images for almost everything that matters. Reserve instance store for truly ephemeral data paths. Move images deliberately through create, register, copy, and deregister. And delete orphaned snapshots when you deregister. Know your source. Amazon provided for bases, marketplace when you buy a product, community only with caution, custom golden images for production standards. Build those golden images through automation, keep secrets out, encrypt everything, and expire what you no longer need. Master the AMI, and you master the starting state of your entire compute estate. That is the lever worth pulling.